This tutorial will show how easy it is to perform a nonlinear sequential construction analysis with ETABS. The automated sequential construction in ETABS allows structure and loads to be added in a sequence that matches how the building will be built. We start with a 5-story, 3-bay building. We will remove one of the first floor columns in order to create a transfer girder. Transfer girders are typically vulnerable to sequential construction. This is because if construction sequence is ignored, the analysis assumes that all loads are carried by the entire structure. That is, the loads are carried by this deep Vierendeel truss. However, when the sequence of construction is considered, the transfer girder must initially span the entire distance without the benefit of truss action. Next, we will review the load patterns. For this example, we have default patterns of dead and live. We will be primarily interested in the dead load due to the fact it contains the self-weight of the structure. Next, we need to define how the building will be constructed, that is, the construction sequence, which is easy to do in ETABS because this sequencing has been automated via the Auto Construction Sequence Case command. We start by checking the Cases Active checkbox. This allows us to easily toggle whether or not construction sequencing should be performed. Note that the case is given a default name of Auto Sequence. We could also specify geometric nonlinearities if so desired. In the construction sequence area, we can specify how many stories should be included in each group. In some instances, it may be appropriate to use 2 stories or even more, but we will use the default of 1 in our example. In the Loads Applied area, we can specify which load patterns are to be applied. For this example, we will use only the dead pattern. We assume that the other loads are applied after the structure is complete. We can also scale the load pattern case, and for this example, we will use a factor of 1. Lastly, if we want to use the construction sequence load case in place of the dead load case in our design combinations, we can do so by checking this box. This is all it takes to define a sequential construction load case. Now let's take a look at the load case data that the program has automatically generated for the nonlinear construction sequence case. On the Load Cases form, note that a case of Auto Sequence is listed. Highlighting this case and clicking the Modify button, we see that the program has created a nonlinear staged construction case with a total of 5 states, 1 for each story. Note that each stage has 2 operations. With Stage 1 highlighted, when we click the Stage Operations button, we can see the breakdown of the 2 operations. For this stage, the first operation is to add structure, in this case story 1, followed by operation to load the objects just added with the dead load pattern with a scale factor of 1, just as previously specified. We can see the other stages perform the same operations for the other stories as we go up the building. Clicking the Show Tree button shows us the same information in a tree diagram. Now that the sequential construction case is defined, we are ready to run the analysis. In the left window, we will display the deformed shape for the dead load case. In the right window, we will change the 3D view to an elevation view. And we'll display the deformed shape from the sequential loading to see the effect that this loading approach has on the building. We start with step 1 and set the scale factor to 200 to match the other display. Step 1 shows the first story in a deformed state. We can toggle up the construction stages and note how the displacement at the transfer girder location grows significantly larger than that of the model where no sequential construction is accounted for. In fact, a right click on the girder shows the displacement to be approximately 1/4 inch for the non-sequential case, while the displacement is more than doubled when sequential effects are included. Next, we will change the left window to show the moment diagrams for the dead load case. In the right window, we will again show the results for the sequential construction case. Once again, the moment diagram for the transfer girder is significantly larger in the sequential construction case than that for the case where the entire model acts together. This concludes this tutorial on automated construction sequencing in ETABS.